Hello. Today's video involves net change of a function. We are looking at now applications of the antiderivative. First being the most basic application, the area under the curve. We've talked about that, and now we're going to diversify just like we do with derivatives and talk about applications, other applications. And let's suppose that I have the following. A particle moves so that the velocity at time t, where 0 is less than or equal to t is less than or equal to 10, is given by v of t is equal to t squared minus 6t plus 5 feet per second. What is the displacement of the particle in time interval from 0 to 3? Okay? So, in this case, the displacement is given by the integral from 0 to 3 of t squared minus 6t plus 5. This marker is dying. Okay? The antiderivative of velocity is position, and so what the net change is going to be the antiderivative with the limits from 0 to 3. What is the change in the position as we go from 0 to 3, time 0 to time 3? And so this is rather simple. This becomes 1/3 t cubed minus minus 3t squared plus 5t, evaluated from 0 to 3, which gives me then 9 minus 27 plus 15 minus 0, 0, 0, 0. And that comes out to be, negative 3 feet. The particle actually starts by moving forward first for the first second, then it moves backwards for the next 5 seconds, and then forwards. And so in this case, overall it ends up actually going backwards negative 3 feet. Now, another question from the same problem here. So I'm going to erase this bottom part. And I want to know what is the distance the particle travels in the interval from 0 to 3 seconds. Okay, now, as I mentioned before, this particle moves forward and backward, and so taking the integral directly, as I just did, is not going to give us the distance. Some distance is covered that gets, we end up going back on itself. And so what we need, the distance, then, is still the integral from 0 to 3, but now it's the absolute value of t squared minus 6t plus 5, because I want this thing always to be positive. Now, this causes a little bit of a problem. Fortunately, in this case, this function factors, and so this is t minus 5 times t minus 1. This is what I was referring to previously, that it moves forward at first and then backward after that. And so now Notice that the signs of these things change at 1 and 5. Of course, 5 is outside the interval that we care about, so 1 is the one that's important. And so we have to break this apart. We have the integral from 0 to 1, and in that interval, both of these on the inside are negative. And so in reality, we get the negative of t minus 5 times the negative of t minus 1, which obviously just comes out to be the original because of double negatives. And so I end up with t squared minus 6t plus 5 in this piece. I need to change a marker. But plus, we have the integral from 1 to 3, and in that piece, the t minus 5 part is negative, but the t plus 1 part is positive when I take it out of the absolute value. So again, I'm going to write this as I did before. It's the negative of t minus 5 times positive t minus 1. And notice what happens here. In this case, I get plus the integral from 1 to 3 of negative t squared plus 6t minus 5. I'm just multiplying this by a negative. This changes all of my signs, which means my antiderivative for the first part, 1/3 t cubed minus 3t squared plus 5t, and this will be evaluated from 0 to 1 plus, and in this case, the antiderivative is just the negative of the previous antiderivative. Negative 1/3 t cubed plus 3t squared minus 5t, and this goes from 1 to 3. And of course, now we have to input our values. This would be 1/3 minus 3 plus 5 minus 0. I put in 0 plus negative 9 plus 27 minus 15 minus negative 1/3 plus 3 minus 5. And then we have to combine all this together. What I usually do is kind of deal with the integers first and then the fraction second. So this is going to be 2. This is going to be positive 3, which is 5. And this is going to be negative 2. So the overall, that gives me positive 3. And then I'll deal with the fractions part. I have positive 1/3 plus 1/3 is 2/3. And so therefore we end up with 11/3 feet. That is the distance.